Chapter 2, Section 3 is about freefall. So we start by looking at Captain Underpants. Captain Underpants, as soon as he leaves my hand and enters the... Oh, and then hits the ground. Okay, as soon as he leaves my hand and right before he strikes the ground, he is in freefall. So if you observe, Captain Underpants is in freefall from now until now. Now, we can just say that he is in freefall as long as the only force acting on him is the force of gravity. Bless you. So, an object is in free fall if the only force acting on the object is the force of gravity. Now, unfortunately, at this time, we can't really use this definition for when an object is in free fall, because we have not defined the concept of force, and we don't know what the force of gravity is. So we can't really use that. We'll get there in a couple of chapters, so we have to look at it differently. So, you'll observe that Captain Underpants, who's in free fall from now until now, is in free fall from the moment he leaves my hand until the moment he touches the ground. Which means, for now, we could say that he is in free fall as long as the object is not touching another object. And one other piece. Anybody know what the other piece is? Because it turns out that Captain Underpants actually is not in free fall right during that piece. Captain?
Something to do with air resistance?
There can't be any air resistance. So the object is not touching another object, and there is no air resistance. Okay, so take a moment, inhale, exhale, realize that you are now breathing what I like to call the vacuum that you can breathe. From here on out, you will be in the vacuum that you can breathe. Every once in a while, we will step into the air and talk about what happens because of the air, but from here on out, every problem you do, every time we talk about anything, we make the assumption that we live in the vacuum that you can breathe. Class, do you understand?
Yes.
Great. So, what does it mean to be in free fall? One thing to make sure that you understand about free fall is this. The word fall. People have a tendency then to assume that Captain Underpants must be falling down in order to be in free fall. That is not true. He is in free fall even on the way up. Okay? So as soon as he leaves my hand, he is in free fall. Regardless of the fact that he's moving up, he's still in free fall. So there's one common problem with the term fall in free fall. When an object is in free fall, the acceleration of the object in the y direction is equal to negative little g, where little g here on Earth, where g is called the acceleration due to gravity, the acceleration due to gravity, little g here on Earth, is 9.8 meters per second squared. Which means the acceleration in the y direction is equal to negative g, or negative 9.8 meters per second squared. A couple of points about the negative. Little g, the acceleration due to gravity, is positive 9.8 meters per second squared. However, the first time I introduced little g, which is today, the acceleration in the y direction is equal to negative g, which means the acceleration in the y direction is equal to negative 9.8 meters per second squared. So people get it in their heads that g is a negative number. It is not. little g, the acceleration due to gravity, is a positive number. Every other time we use it, it will be much more obvious that that is true. But for some reason, the first time we introduce it, the acceleration due to gravity is equal to positive 9.8 meters per second squared, but the acceleration in the y direction is negative g. Now, that negative simply means the direction, which is down. Negative y, right? The acceleration in the y direction is negative 9.8 meters per second squared, which is negative y direction, which is down. One other little thing is that, unfortunately, I'm going to be writing this number, 9.8, on the board literally thousands of times during this school year. So, because of that, I will not be writing 9.80, instead I will be writing 9.8. It turns out that here on the second floor of Northville High School, the acceleration due to gravity is approximately 9.8045 meters per second squared. So it rounds to something close to 9.81, 9.80. We generally treat it as 9.80. Sometimes you'll read it as 9.81. Truth is, it doesn't really matter. We'll talk about it at some point, the fact that it is actually not quite constant as well. But so 9.8 with 3 sig figs. And I apologize for that, but as I said, I'm going to write it several thousand times. So 3 sig figs. Now, considering the fact that an object that is in free fall is experiencing an acceleration in the y direction equal to negative 9.8 meters per second squared. Sandra, this means it is what type of motion? No, not what I'm looking for. There's a specific term I'm looking for. That's okay. Are they? Yes. There's more though.
Accelerated motion.
Yes, except it's an adverb. Uniformly. Uniformly accelerated motion. Notice, because the acceleration equals a number, you could see that free fall is simply uniformly accelerated motion, where we already know the acceleration. It's 9.8 meters per second squared in the negative y direction or down. It's a common misconception that on the way up, the acceleration would be positive 9.8 meters per second squared, and on the way down, the acceleration would be negative 9.8 meters per second squared. For some reason, because it's moving up, people have this idea that the acceleration needs to be positive. So, who could tell me what would happen to Captain Underpants if the acceleration were positive as he were moving up? Positive y, positive 9.8 meters per second squared. Neil?
He would continue speeding up.
He would accelerate upward like a rocket, right? That's what he would do. Is that what happens? No, he slows down. That's what the acceleration being negative in the y direction means. As he has a positive velocity moving upward, that negative acceleration slows him down.